Okay, we're going to jump into lesson 3.1, which is going to be on the intro to graphing quadratics here. So we're going to start to look at parabolas. These are going to be our U-shaped graphs here. And a couple things to point out. Quadratics, we've seen them before, we just haven't graphed them. Just a reminder, quadratics means that our largest exponent is 2. So in this case, we've got x to the second power. That tells me I'm going to have a quadratic equation, which means that it's going to look like this U-shaped graph, which is called a parabola. Okay, and we've got two options right now. That's the parabola can either be facing upwards or it can be facing downwards. All right, and then that's going to be dependent on what my coefficients are for x squared, and that's what we're going to jump into right now. So we've got two options here. And the first is that we've got our quadratic equation, and notice it goes ax squared, so the variable for the x squared, or the coefficient for x squared is a. The coefficient for the x term is b, and then we've got our constant, which is the number in the back here with no variable, which is identified as c, and each one of these coefficients is going to play a role in what my parabola looks like. So the first piece is this a value. Okay, and the a value is going to determine which way my parabola faces. Does it face upwards or does it face downwards? All right, so if a, I've already written this in, so you can fill this in, pause the video if you need to. If a is less than 0, which means that a is a negative number, right? If a is a negative number, then my parabola will be facing downwards here, which means that it's going to have a maximum value, right? So it's going to have this dot here at the top, which is the maximum value. It won't have a minimum value because it just keeps going down and down and down and down and down forever and ever, right? But it will have a maximum value at the top. All right, so if a is negative, right, if a is less than 0, we have a maximum value because my vertex is at the top. We're going to talk about vertex in 1 second. And then if a is greater than 0, so now it's a positive number, right? It could be like 1x squared or 2x squared or 3x squared. Then my parabola will be facing upwards, which means now my vertex is going to be at the bottom, which means it has a minimum. This parabola would have a minimum, so it has a low point, but it doesn't have a high point because it just keeps going up and up and up and up and up forever. All right, so that brings us to what we've got here. We've got this point here, which is at the bottom, and so we'll call that the minimum. That's a minimum because it's at the bottom of my parabola there, and that's the vertex. So the min or the max is going to be the vertex, and similarly over here, this time the vertex is at the top, so this is going to be the max. Right, so this is a max vertex. Okay. All right, so that's what A is going to control. So it's going to control which way my parabola faces. And we'll talk about a couple more things here. So this first one, it says A is equal to 1. So 1 is a positive number. So right off the bat, I should be thinking that my parabola is going to be facing upwards, right? It's positive, it's smiling, right? So it's facing upwards here. So I'm going to go ahead and start this vertex at 0, 0, right? Right now, we're just kind of sketching this, so don't worry about the exact points. And it's going to look something like this. Okay, and so it's facing upwards because it's positive and it's starting there at 0, 0, and that means it has a minimum because the vertex is at the bottom. All right, now as a gets bigger, so now a is greater than 1, so this could be like 2, 3, 4, 5, right? So as a gets larger, what happens is my parabola actually gets skinnier, it gets more narrow. So as that number gets bigger, my parabola is going to get more narrow. But it's still facing up because it's a positive number, so it's still a minimum. And now as a becomes a fraction in between 0 or 1, so now this would be like 1/2 x squared or 1/3 x squared. So as it gets closer and closer to 0, notice those are still positive. So it's still going to be facing upwards, but it's going to make my parabola wider. So it's still facing up because it's a positive number, but now it's getting closer to 0, so it's going to be wider. And then it's still a minimum because it's still, this point is still at the bottom, the vertex is still at the bottom. All right. Similarly, now we have a is -1, So this is going to be facing downwards because it's a negative number. And then as it gets more and more negative, okay, so -2, -3, it becomes skinnier, so more narrow, but still facing down. And as it becomes a fraction that's negative, right, so in between 0 and -1, still facing down because it's still negative, but now it's going to get wider. And for all of these, notice the vertex is at the top here, so that's going to make all of those maximums. All right. Okay, next one is the b term. So just let me remind you, b term is up here at the top, right? The middle term connected to x here, that's the b term, all right? And so sometimes we'll call it the middle term or the x term. And we have this note here, so you can write this down, maybe pause it if you need to. It says if b is equal to 0, so that means there is no middle term, right? So the x term is just basically gone. If b is equal to 0, the vertex and the y-intercept will be the same point. And we're going to see that in a second. So if b is equal to 0, the vertex and the y-intercept will be the same point. All right, and then we have the c term here. That's the last term that's got no variable, right? And this is important here. The c term is going to be the y-intercept. So right off the bat, when you look at your equation, you'll know the y-intercept. Remember, that's where the graph hits the y-axis, just like you've done in linear equations. So here's a quick picture of a parabola here. And notice something about these parabolas is that they are symmetric, right? So they're the same on both sides, and that means they have a line. This is an imaginary line that goes right down the middle. It goes right down the middle of my parabola. And that line is called the axis of symmetry, okay? And so that line hits the x-axis. Notice it hits the x-axis, right? It goes through the x-axis there. And we can figure out where it hits the x-axis, which point it is where it hits the x-axis, using this equation, which is x equals -b over 2a. And so I've jotted that down there. X equals -b over 2a. That basically tells me where the middle of my parabola is going to be. And then we can find the vertex, because the vertex is a point, right? It's going to be something like 5, 3, right? Some sort of ordered pair. And it's always going to be the axis of symmetry, comma, whatever the y value is, right? So what that's basically saying is that the vertex, it lies somewhere on the axis of symmetry, right? In this case, it's down there, okay? But we can find it's going to be somewhere on that axis of symmetry, that middle line there. All right, that's a lot of information. We're going to go through it step by step here, okay? And you'll start to pick it up as we go. Okay? So I've jotted down the steps for graphing. You can go ahead and pause and write those down. I'll go through them quickly here. It says identify A, B, and C, find the axis of symmetry, find the vertex, find the y-intercept, find the x-intercept, and that's only if this is going to be factorable, right? So it won't always ask you for the x-intercepts. Keep that in mind. And then if we need to find more points, we can always make a table just like we do with any graph. We can always make a table. All right, let's jump into the first one here. We'll go slowly just so you can pick this up piece by piece. First, I'm going to identify A, B, and C. That's the first step we have. So A equals, in this case, it's 1x squared. So A is 1. B, there is no B, right? There is no x term. That means B is 0. And C is -2. So we've got A, we've got B, we've got C. All right, next we're going to go ahead and say find the axis of symmetry, and we've got an equation for that. All right, I'm going to say axis of symmetry, AOS for axis of symmetry, and my equation is x equals -b over 2a. And so then I'm just going to punch in what I have for my values here. This is going to be -0 over 2 times 1. And then, of course, if the top of my fraction, my numerator, is 0, then this whole thing is just going to turn into 0. So I get x equals 0 for my axis of symmetry. All right, x equals 0 for my axis of symmetry. And now I'm going to scroll to the right, fill this in on my graph and on this line that they've given me here. So axis of symmetry is going to be x equals 0. Okay, and so what that means is the middle of my graph is going to be right down the middle here where it hits 0 on the x-axis. So basically it's laying on the y-axis here. So the middle of my graph is right there. I don't know where my graph starts, right? It could be something that looks like this, could be something that looks like this, right? It could be something that looks like this. I don't know exactly where it is, but I know that the middle is going to be right down the y-axis there, where it hits 0 on the x-axis. All right, so we got to find the rest of this. Next, I'll find the vertex. Okay, and so to find the vertex, I'm going to take my axis of symmetry point and I'm going to plug it into my equation. So my equation is this: y equals x squared minus 2. Remember, that's the equation that we started with here at the top. And I'm going to take what I have for x, and I'm going to punch it in to find the y coordinate of my vertex here. So I'm going to say y equals 0, because that's what I got for x, 0 squared minus 2, which means that y equals negative 2. And so then my vertex is going to be 0, negative 2. Okay, and so one more time, that was the x coordinate that we already found from the axis of symmetry. I just plugged it into my original equation, and I found negative 2 as the second part, right? The y coordinate of my vertex. And so now I'm going to go ahead and plot that on the right. The vertex is at 0, negative 2. And so I'm going to go to that point, which is right here, and plot the vertex. Okay. So now we got the vertex. Now we'll go ahead and find the y-intercept. All right, remember the y-intercept is quick and easy. The y-intercept is always just going to be whatever the c value is. In this case, we have the c value at negative 2, and so we've got 0, negative 2 as my y-intercept, and so that's all done and dusted. So the y-intercept is at 0, negative 2. Notice it's the same as the vertex, and we said that was going to happen on the other page if we have no b value, if we have a 0 for the b value. We can also see this negative 2 is already lying on the y-axis, right? So we know that that would have to be the y-intercept because it's hitting the y-axis there. All right, so it says find the axis of symmetry, got it. Find the vertex, got it. Find the y-intercept, got it. Now, we're not going to find the x-intercept because it's not asking us here, but we do need more points, right? Because we don't know how wide this graph is going to be, how wide this parabola is going to be. So I can make a table, and so I'll go ahead and do that. I'm going to make a table here, x and y. I'm going to pick an x value here. I'm just going to pick 1 because it's easy. Remember, I get to pick those x values, and I'm going to plug it into my equation here, x squared minus 2, to find the y value. So that's going to be y equals 1 squared minus 2, and I get y equals, 1 minus 2, and so the y value is negative 1. And so then I'm ending up with this point, 1, negative 1. Okay, and I can put that on the graph here, 1, negative 1, which is right here. And now this is the nice part about these parabolas. Remember, they're symmetric. So if I zoom it in big time here, notice that this dotted line, right, the axis of symmetry goes right down the middle. So if I have a point that is 1 to the right, then I also have a matching point that is 1 to the left. So I'm going to go ahead and fill that point in there. All right. And we could find more points using our table, but for now, this is good enough, right? We have enough to know that my graph is going to look something like this. Okay, hits those points and goes upwards, right? We know it's going up because A is positive, so we know it's going to be facing up. All right, let's go through one more here.